Okay, so this is just a redoing of an example that we covered today from section 9.5. I wanted to do it a little more clearly, and so in this problem, and feel free to pause the recording if you need to copy something down, but let me go. I'll go through the problem here. So we want to find an equation of a plane that passes through the point 1, -1, 1, and contains the line with symmetric equations x equals 2y equals 3z. Now, we note here that the point 1, -1, 1 is not on the line with this symmetric equations, with these symmetric equations, because 1 is, for instance, not equal to 2 times -1, right? So like if I take the x and y coordinates of this point, I can see already they don't satisfy the symmetric equations. So this means then that what we have is we have a situation where we have a plane. Okay, we have a plane, and we have a line in the plane. Let me get that. Okay, we have a line in the plane. Okay, and we can call that like line L. And then we have a point right here, 1, -1, 1, that's not on that line. So we actually saw this in an example we just did, where what we're going to do is we're going to find 2 points on this line, right? We're going to find 2 points on that line, and then once we find the points, we're going to find the vectors, these 2 vectors. I'll call the one vector A and the other vector B. And if we take the cross product of those 2 vectors, that will generate a normal vector, right? Normal vector to the plane. The vectors A and B are in the plane, so the cross product of the vectors A and B, the cross product will be a vector that is normal to the plane. And so once I find that normal vector, I can use that and the point in the plane, the 1, -1, 1, if I use that point, which I'll use, and to find the equation of the plane. So what I have to do, of course, is I have to learn more about the line. Well, I'm given the symmetric equations of the line, x equals 2, y equals 3z. And if I go to the solution here, remember for symmetric equations are of the form x minus x naught over A equals y minus y naught over B equals z minus z naught over C. So the symmetric equations here, x equals 2, y equals 3z, I write them out this way, okay, this way here, so that I can identify a point that the line passes through and the direction that the line goes. Well, the point that the line passes through is going to be actually the origin. And so that's how I get 0, 0, and 0 here. And the direction vector that the line moves in is going to be the 1, the half, have components 1, a half, and a third. And that's how I get 1, half, and a third here. So given that, now that I know the parametric equations of the line, and again, you can pause the recording if you need to. Now that I know that, I can pick just two values of t. I chose t equals 0 and t equals 6. And that then I find that the points that when t equals 0, the origin, that generates the origin, and when t equals 6, that generates the point 6, 3, 2. So the points 0, 0, 0, and 6, 3, 2 are going to be on that line. And so now the A and the B, what I do is I go ahead and take, like for A, I take the terminal point 0, 0, 0 on the line and subtract the initial point -1, no, the initial point 1, -1, 1. And I get the point, I get the vector -1, 1, -1. Similarly for vector B, I take the terminal point 6, 3, 2, that's the point on the line, 6, 3, 2, second point on the line, and then subtract the initial point, and I get 5, 4, 1. And that's the easiest way to do it. And now what I do is I take the cross product of A and B, and I get the vector 5, -4, -9, and that will be the vector normal to the plane. Okay, so given that then, now that I have a vector normal to the plane and I have a point on the line, a point on the plane, I have 3 points on the plane, but I'll just use one of them, of course. Now I take that vector 4, 5, I take that vector with components 5, -4, and -9. 5, -4, -9. And, you know, and then I use the, well, actually, no, I use the point, I use the origin. That's the easiest point to use for the point on the plane. I use the origin, actually, but I don't have to. And when I work it out, I get the equation of the plane, 5x minus 4y minus 9z equals 0. Okay, so I hope this was helpful, and I will stop the recording. Thank you. I'll stop the recording.